Okay, on this one, you have to legibly draw three equivalent resonance structures for the carbonate ion. So, carbon and oxygen, you have three oxygens and one carbon. Carbon is the least electronegative, I guess, of those two elements, so it's going to be your central atom. So, you have carbon, and remember that carbon has 4 valence electrons. It's in group 4A. Oxygen has 6 electrons, valence electrons rather, and you are going to use 3 oxygens. So it looks like you're going to have to give their central atom an octet, and your oxygens an octet as well. So you're looking at an oxygen 1, 2, 3, 4, 5, 6. Same thing, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So there you've drawn your valence electrons around each individual atom. And now you're going to try to fix those in bonds where you can complete octets for everything. So if you push electrons around, you'll end up with a double bond to one of the oxygens, where carbon can contribute 2 electrons and oxygen can contribute 2 electrons. Then you'll end up with oxygen actually taking that configuration there, and an oxygen taking that configuration there. And then when you draw that, oxygen with one bond has a formal charge of -1, and you could figure that out, which we kind of did previously. But oxygen with a valence of 6 has 6 non-bonded and 1 bond formed. That's a charge of -1. So this oxygen here has a -1 charge, as does this one. So you have a -1 over here and a -1 over here. Oxygen with 2 bonds and 4 electrons has a charge of 0. And carbon with 4 bonds has a charge of 0. So overall, this structure has a charge of -2. And then to draw the equivalent resonance structures, you put an arrow, and you're going to push electrons around and move your double bond. So in other words, you can have electrons, say, from right here, flip down, form the double bond, kick electrons out back over to this oxygen. So you have now oxygen with its double bond to carbon, carbon with a single bond to oxygen and a single bond to oxygen, and your 4 electrons now on that one. But now you push those electrons over here, just like that, and you have another resonance structure. You draw the charge outside the brackets just like that. And then you can just as likely find that double bond being right here as opposed to here or there. So this is going to be your double bond now. And brackets and -2 charge. So again, oxygen with 2 bonds and 4 non-bonding electrons like this is neutral, has no formal charge. And then oxygen with 1 bond and 6 non-bonding electrons has a -1 charge. That's where your overall charge of -2 comes from. When you add up all the charges inside there, 0, 0, -1, -1, you get a -2. And so, here are your 2 -1s over here for this part. So when you add up all the charges, that's what goes out here. So, and that's kind of given in this because at that point in time, you did not have a polyatomic ion list, or you weren't required to know them. Um, you just had to be able to draw the structure with the resonance indicated like that. So the way you do that, draw the structure, the Lewis structure correctly, put it in brackets, put the charge outside, draw arrows between each equivalent resonance structure.